Hi guys, you can see me here standing behind my table and there's a lot of stuff. What are we going to do today? So I have a job and it is installing a new car charger. This one is a 22 kilowatt charger, so a very high power device, and this requires a good job preparation. Usually you would not do something like this by yourself, of course, and it also requires to work on our main distribution. Typically you would also not have the chance to go so deep into the electrical system, but I will take the chance then to explain you about electricity distribution a little bit too. What do they use here in Thailand? Thailand has a three-phase system, similar like in Europe, for example. So the voltages are 230 volts, one phase, and 400 volts, three phase. And the typical car charger, the AC charging here in Thailand, the standard what they use is a one phase 32 amp onboard charger for the car. It means usually only one phase used, but when you use that sort of standard, so we have the so-called type 2 standard, you have many more options, because if you have three phases available, you do have also options to use three phases, and like in Europe the standard would be three phase 16 amps, which is a 11 kilowatt charging. That is actually quite nice because it does not go as hard on your electrical installation, of course, only 16 amps, and this distributed to three phases, so that's quite nice. Here they did not go that way, probably because a typical house installation will have one phase, and 32 amps, that's already quite a lot. I decided to go for the 22 kilowatt charger because 22 kilowatt, what is this? This is just a three-phase charger, 32 amps. This charger can be universally used for any car which comes. Whatever AC charger that car has built in, it will work on this charger, because if it's a standard one phase 32 amp car, it will just use one phase, and if there's by some reason a three-phase car coming 16 amps, it can use this charger. And also maybe if one day bigger cars like vans or something use three-phase 32 amps, it can still charge on this. So all this will be installed at our parking place and right next to the main distribution board. The main distribution board is the first point of our distribution right after the transformer, so we have plenty of power there. I could install three of those there, no problem. But there's also a drawback. The MDB is not really meant to use as a point of small installations, which this still is. The main distribution board is actually built the way that it just takes the massive power from the transformer and breaks it up into a few more other circuits and sends that one to the next distribution points, right? So what we will see is, what we will have to do, I will also make some changes there inside the MDB. For example, want to install surge protection there. So let me show you what I have on the table, and then we will see what we are going to do with this. What do I have on the table? The charging station, of course, straight from AliExpress, so a Chinese brand. You see, 32 amps requires quite massive cabling. We have 5 cores there. You can see that also here in the type 2 plug. Usually when it's one phase you have only these 3 pins, and here we have 2 extra. So this is the Manacas Type 2 plug. So this station is activated by either an RFID or by the phone app. What did I pay for it? So including shipping and customs import tax was about $310. So everything what you see on the table, actually what we need for the installation was maybe around $450. Okay, then what's next? This will be our supply cable, also 6 square millimeters, but you see here in Thailand I have the problem that even in specialized shops you cannot get cables which have the core for earthing inside. So it's a 4 core, 6 square millimeters, and for that, for the earth, I have to pull a extra 6 square millimeter earth wire. All this will be connected to an extra load center. So here, this box will fit the main switch. This will be a 40 amp 4-pole main switch. Then there will be a meter, 3-phase meter, because these cheap stations, they do not log, of course, what they do. And once you finished, nobody knows how much power was actually taken. So a meter and then a 3-phase RCD which will watch over the station. I have some nice tin plates here, some DIN rail. We have to change the MDB a little bit, heat shrink, cream plugs of course, 10 square millimeter wire. This is for inside the MDB. There will be some things to do. For example, I will install a surge protection device right at the entrance of our grid. So this is a good way to get rid of surges which are coming from the outside. A terminal, a bus bar for neutrals inside the MDB. I don't have any neutral bar there for smaller wiring. Of course, some conduits. We will use 1 inch, 25 millimeters for all this. A new main circuit breaker for inside the MDB. I want to change the 3-phase circuit breaker which is there from a 100 amps to a 80 amps. Why that exactly is like that, I will explain you later. Then at the cabinet, in this cabinet, all the cables will kind of come together, go to the other places, and also the charging cable will be then stored. Okay, that's about it. So we're going outside to the place where this will be all installed, and yeah, then just start with the work. At some point I have to remove all the power from the resort. So in that case, of course, there's a few guests here. I need to inform them that they will be without power. Okay, I told you I want to have my cable inside a locker. So in order to do that, I of course have to remove the cable here from the charger, from the wall box, and yeah, to put it through a hole there. But this gives us the chance to look inside such a charger here. It's not overly complicated because a wall box is actually only a broker between the car and the grid or your power supply. And so what it is, essentially it is a relay unit, right? So you have here power in, power out. It goes over relays and current transformers to do some measurements, and that's already it. Here's the emergency switch, and on here on the lid the controller unit, Wi-Fi, and the RFID unit. So nothing too complicated, and what I have to do now is unscrew all these terminals here, remove the cable, put the cable through my hole here into the cabinet, and yeah, then I can close it up again. Now you see the charger is part of the cabinet and it cannot be carried away so easily. This is the station which we have here at the moment. So this one is a one-phase 32 amp station. It's very nice. It's controlled by touch screen. When I bought it, they promised that it would also work with RFID, but that was then not true. RFID is not installed. And yeah, here on the down, as you see, I have a box, and this is where the cable is in, and this will be also the same at the other place, so I can lock up the cable that nobody is coming to the idea to take it. So this is at the garage. It was one of the first charging stations in the district here. Here's our car park, and this is of course the best place to put a new car charger. And the new car charger, you can see it here, safety first. I already closed up the place. This here, our main distribution board, and the charger will come here to this wall. We will put some conduit from there to here and connect everything. Right, so this part now is mounted. Charger, its load center and the box. So there will be then the next, what comes is the conduit, which will run from here over the trench into the MDB. And yeah, then I will put the cable inside and we can start connecting all of this. But let's talk about the main distribution board. This is actually the first distribution right after the transformer. The transformer comes in here via these very big cables here, and the first it meets is the main breaker. It's a three-phase 250 amps breaker, and what that breaker is actually doing, it is just protecting the next portion of the distribution, which would be this inner core here. These are all quite big bus bars, and they then go to other breakers, which then take cables to the next distribution points. So in the initial parts of the distribution, the only thing what is taken care of usually are short circuits. So these massive breakers should never trip when something at the later parts, downstream distribution kind of happens, right, in your load centers, in your buildings, etc. These breakers should work only and trip only when something happens, like this one, which is our main breaker of interest today. When something on these wires here, which are connected from this side and running to the next distribution point, if at that point on that wire something happens, a short circuit, then this breaker would be responsible to trip. So it's not about overload or even leakage or anything like that, only short circuits. Breakers or fuses in the early parts of the electrical distribution do have the purpose of short circuit protection, protecting the cabling from this point to the next distribution point. So if in case an excavator is digging up a cable, or somebody carelessly digging something and hitting a cable causing a short circuit, then these sort of fuses or breakers have to trip. But how do we know how to dimension these breakers here? It has something to do, of course, with the cables you use and the distance to the next distribution point. So for example, this 3-phase 100 amp breaker is protecting 10 square millimeter wires, which are 110 meters long. If we now look up what resistance a cable of that length and diameter has, the short circuit at the 110 meter point, so the current goes 110 meters there, coming back the 110 meters, so the cable length for the short circuit is 220 meters, and that cable would have a resistance of around 400 milliohms. And if you now say, okay, that short current occurred between a phase and a neutral wire, this would cause around 550 amps of short circuit current. 550 amps on a 100 amp breaker. That sounds quite okay. But if you look up how these sort of breakers work, you will find out in their data sheet that typically you will need around 3 times the nominal current to make such a breaker trip quite instantly. So we need 300 amps minimum to trip this breaker safely, and 550, that's quite a good value over those 300. So we could actually be sure in this current condition would actually work quite well. But still I want to change it to be an 80 amp instead of the 100. So why is that? Probably you will think about that has now something to do with my charger here, because we are going to connect this 3-phase cable, this is a 6 square millimeter, at the same breaker like the 10 square millimeter is, which goes to the main building. So the breaker will actually serve both of the lines. So 6 square millimeter, less diameter, yeah, so I will probably need a less amperage breaker, but this is actually true. This cable here is 5 meters long. The next distribution point, so the load center of the wall box, is only around 4 to 5 meters away. So in the case of a short on that line here, we only have around a maximum cable distance of 10 meters, and the 6 square millimeter wire over the distance of 10 meters there and back, right, only has a resistance of around 30 milliamps. So if there's a short 5 meters away from the MDB, there would actually be a current of around 7,000 amps flowing, right? If the transformer can put out that current for a short time, this could really happen. That's why if you look in these breakers, they have surge currents in case of short current up to, like this one here is 7,500 amps. So these are massive currents. So changing this breaker from 100 to 80 has nothing to do with our new line here. I just want to increase the buffer from around 5.5 times the nominal current to the 7 times the nominal current, and the restricting cable is still that one to the main building. 80 amps is still enough for the load, so this breaker will not be overloaded. Overload protection, leakage protection, those kind of things are always taken care inside the load centers, right? MDB is wired up. I have the power already here at my main breaker. So we will talk about the MDB a little bit later, but we can check now if everything is correct. So this is the perfect meter for this. We can check 3 phases very easily, and the meter will not just show us correct voltages, like now 400 volts phase to phase, 230 phase to neutral. We can also check the field of rotation of the 3-phase system. So this probe is marked L1, this L2, and when I hold this to L1, L2, I also see here an arrow, and this time it's shown at the right. So we have right field of rotation, which is the standard at installing 3-phase systems. So we can also go between phase L2 and 3, still right. If I would hold now L1 to L3, then it's going to the left, so it's a wrong field. I would have to turn my probes. Okay, so everything is fine here. I will just continue now. Now the next is the meter, then the RCD, and then the box. Right, everything is connected now. You can see here we come in. Very easy, just take every wire, bring it to its terminal, just from one to the next, and then we are there. We can now try to power it up. Main switch is on, and we can already see the meter is showing, and we also have LEDs here for every phase, and yeah, it powered up also well. Okay, now we only have the RCD here. Put this one up, and it already gives us power to the wall box. But let's test it first. This is rather old one. I brought it from Austria, probably already 20 years old. The test is working. This test is of course only telling us the internal test is successful, but we can test it also externally. What I have to do is I can take here ground and go to one phase, so we see 230 amps, and if I pressing now these 2 buttons, we must actually activate the RCD, and it's perfectly working. Yeah, the wall box is showing us a nice display. We can see voltages, we can see the amperage which is set. The wall box is actually quite nice because you can set different output amps. So you can set, as you see, 8, 10, 13, 16, 25 and 32 amps. So if somebody does not want to charge as quickly and you want to maybe charge by the solar during the daytime, not use up too much energy at once, this can be also set here on the station. So very nice. Let's take a look into the MDB, what has been done here. So I told you I have installed the surge protection. I wanted to connect it here on the main screws there on the bus there, but that was impossible to open those screws. So because I already replaced this breaker, I just connected them there. The new breaker, everything a little bit cleaned up there. Here the neutral bus bar, the new one, which is connecting a few things from the AC power wall as well. That was it for today. So if nobody asks you, would you do it by yourself also? It's nothing complicated, of course. The only challenge was to combine this here into our distribution system, which is not really meant for that at this point, of course. But yeah, I have to wait now for somebody who has an electric car. Unfortunately, I don't have one, so I cannot test this. YouTube will also not help me to get one. It will probably take around 200 years. But no problem. There will be some guest and we can check the station. Thank you for watching this video. I hope you found it interesting. Please like, comment, subscribe to the channel, and I see you next time.